Hi, I'm Alex,
And I'm Ben.
and we're presenting on atmospheric circulation and the Coriolis effect.
First off, let's define what atmospheric circulation is. Atmospheric circulation is the large-scale movement of air by which heat is distributed on the surface of the Earth. Most atmospheric circulation occurs in the troposphere, which is the lowest layer of the atmosphere.
Air moves over the Earth's surface in the atmosphere because there are horizontal differences in pressure. Air also moves vertically due to physical barriers such as mountain ranges, as well as changes in buoyancy, which is a tendency of an object to float in a fluid. It's no secret that hot air rises, and buoyancy can help explain this. Essentially, heating air causes it to expand and decrease in density, causing the buoyant force of that body of molecules to exceed downward gravitational drag forces.
However, pressure is also worth considering. Air naturally moves from higher to lower pressures to achieve equilibrium in the system. Also, if we measure the distance between these high and low points, we can calculate the pressure gradient. This can be useful in viewing changes in other properties, such as volume or temperature, across the system given the ideal gas equation. And in this equation, we can see V is volume, T is temperature, N is the number of moles, and R is the gas constant.
As heated air rises in the atmosphere, it is forced to diverge poleward. This creates a low pressure zone at lower areas of the atmosphere for air to converge towards, creating a circulation loop. The combination of converging air in the tropics and diverging air in polar regions contributes to the pattern of air movement known as Hadley cell circulation, named after British meteorologist George Hadley.
One may expect air rising at the equator to fall at the poles, but there are actually multiple cells roughly divided to every 30 degrees of latitude. This is due to atmospheric constraints in the troposphere that alter wind circulation, resulting in the distinct Hadley, Ferrel, and polar cells.
These surface winds and pressure differences result in horizontal wind movement known as the Coriolis effect. As we can see here, any two objects initially moving parallel to each other will tend to converge at some point on Earth. This explains why you need a different velocity to move along the same longitude when in different latitudes.
When applied to surface winds, we can see that winds are deflected to the right in the northern hemisphere and to the left in the southern. When applied to a system of variable pressures, we can determine a clockwise or counterclockwise flow based on whether molecules tend towards or away the center. Such trends explain why hurricanes always seem to turn counterclockwise when reaching the east coast.
Although this model is not completely accurate, it provides a good model for understanding atmospheric circulation.